We are doing integration of trig product kind of functions. We did the few cases where one of the sine or cosine's power was odd, but here is the case when both sine and cosine have even powers. What do we do then? Okay, so in that cases, we are going to use two formulas which we learned in pre-cal class. Sine square theta is 1 minus cosine 2 theta by 2. So that's a double angle formula to convert sine square into double cosine angle. And then there is formula for cosine square theta, which is 1 plus cosine 2 theta by 2. So these are really important double angle formulas. We can use them to solve our question here. Now pay attention, this is sine square theta, but this is cosine 4 theta. I can write it as cosine square theta's square. Does that make sense, right? Square of square is just power 4. Now sine square theta can be replaced using this 1 minus cosine 2 theta by 2. And cosine square theta can be replaced by 1 plus cosine 2 theta by 2. But there is a whole square with respect to theta. You guys notice this 2 and this is 2 square. That will be 2 times 4, 1 by 8 will come out. We have 1 minus cosine 2 theta times 1 plus cosine 2 theta square d theta. We'll have to expand it out before we can integrate this. 1 by 8 integral 1 minus cosine 2 theta. This thing can be expanded. If you guys remember the rule a plus b whole square from algebra, a squared plus 2ab plus b squared. So in this case, a is 1, b is cosine 2 theta. A square 1 plus 2ab is 2 cosine 2 theta plus cosine square 2 theta d theta outside. We need to distribute everything inside. 1 times 1 times everything actually, minus, we also would need to multiply everything with cosine. Okay. Here we need to see if we have any like terms. For example, this and this. 1 by 8 outside. 1 is here. 2 cos theta minus, that will be cosine 2 theta. And then cosine square theta, and this is negative, so that will be negative cosine square 2 theta. And this is only negative cosine cube 2 theta d theta. I'm going to separate these out because 1 minus cosine 2 theta, we can handle it now, minus cosine square 2 theta has to be handled differently, minus cosine cube theta has to be handled differently. Okay, so what are we trying to say? This first one, now we can directly integrate, but this one should be converted into again using this formula here. Okay, so let's see. The integral of this one, I know now, 1 by 8. One's integral is just theta. minus integral of cosine ax dx was what? Sine ax by a plus c. So this would be sine 2 theta by 2. Okay, so that part is done. Minus 1 by 8. This here can be converted again into cosine double angle formula. So this is double of 2 theta. Now it will become 4 theta by 2 minus this last one here is cube. Cube is odd power. So remember we have to peel one cosine in odd power cases. The first one we are done with. To move a little bit, I'll show you guys the whole picture after I'm done. 1 by 8 theta minus sine 2 theta by 2 minus 1 by 16, 2 comes out. 1's integral is theta plus cosine 4 is sine 4 theta by 4. So basically we are done with integral of the second portion too. What about this last one though? We are still not done. So this thing can be replaced by 1 minus sine square theta cosine theta d theta. For just this part, I need to substitute sine theta as u. So u sub technique, du will be cosine theta d theta. So which is already there. This can be 1 by 8 theta minus sine 2 theta by 2 minus, we can open this up actually, theta by 8 minus sine 2 theta by 16 minus theta by 16 minus sine 4 theta by 16 times 4 is 64 minus 1 by 8. This thing here can become 1 minus u square because you put, and the remaining thing is du. Theta by 8 minus theta by 16 would be just theta by 16 minus sine 2 theta by 16 minus sine 4 theta by 64 minus 1 by 8. Integral of 1 would be u. Integral of u square would be u cube by 3. So we are done with all the integrals plus c. But pay attention, we need to write sine in back in place of u. So our final answer, theta by 16 minus sine 2 theta by 16 minus sine 4 theta. What am I writing here on my board? 64 minus 1 by 8 sine theta minus sine cube theta by 3 plus c. This should be your final answer. And this is the whole question. So one more time as a recap, we did this question when both of the sine and cosine have even powers. When they have even powers, we need to use these formulas to replace them into double angles, distribute, and then work out the problem as we go. If we simply have a cosine double angle, we can directly integrate that. If there is a square even power, which is again, and then we have to convert again to 1 plus cosine 4 theta by 2. But if it's odd power, we use back the odd power technique.